Okay, welcome to CE 526. Today's topic of discussion is systemic safety, another one of those proactive approaches of assessing safety. And this proactive approach does rely on crash data, but does not only rely on crash data. So it sort of looks at crashes, but it also looks at other pieces of information that you have about your network in a jurisdiction. And then you learn about how we can apply the systemic safety approach. And I'm going to focus on, in particular, with regards to pedestrian crashes. So proactive safety approaches to take, or a systemic safety approach to take to address the issue with regards to pedestrian crashes. And what we are going to do is, we are going to rely on one of the recent National Cooperative Highway Research Program study that was completed in 2019, I believe. So very recent study, and they focused on how we can do systemic safety with regards to pedestrian crashes, because pedestrians are one of the most vulnerable road users on the road, and bicyclists as well. But this research was focused on pedestrians. But I think the project itself, the talk that I'm going to have today, would address the basic elements of systemic safety. So you will have some ideas about how you can sort of generalize this approach, not just to pedestrian crashes or bicyclist crashes, but even more broadly to all different types of crashes. It is definitely more important for crashes that are more rare. Pedestrian crashes are in fact rarer because we have a sort of low number of pedestrians in certain cases. But obviously those crashes are most important, because when pedestrian is hit by a car, by an automobile, the chances are that crash is going to be more likely to be more severe in that scenario. So again, very important to analyze pedestrian crashes, but we'll talk about systemic safety as a function of, for pedestrian crashes. But again, the approach is more applicable to a whole host of crashes. You could apply it to any type of crashes. If you're working at a city, or you're working for a jurisdiction, I think those types of approaches are fairly good to apply, and they do rely on crash data. So the starting point for this would be crash data, but then you have to combine it with other information, your judgment, and just not try to chase hotspots in that scenario. Okay, so what I'll do is I will go ahead and start to share my screen here. So I'll go ahead and hide this now. Okay, so everybody can see my PowerPoint now? You guys can see the PowerPoint? Okay, perfect. So that's great. So what I'll do is I'll just kind of make this up top and hide the video panel. Okay, so this presentation comes from the NCHRP Research Report 893. I believe the project number was 1773. I haven't made this yet available. So project number for this one was 17-73. So this started in 2017, but ended sometime in 2019. So this is talking about systemic safety, pedestrian safety analysis. But again, the systemic approach that we talk about broadly is applicable to more crashes, more different types of crashes than anything else. So again, I want to acknowledge that this work is directly the results of that. One of the webinars that I attended a couple of years ago, and I've sort of slightly modified that PowerPoint, but the content itself is coming from the presentation provided by the research team. So I want to make sure that I acknowledge the team that actually made this happen. This is from Highway Safety Research Center at the University of North Carolina. I know some of those folks, and they serve on the same TRB committee that I do. Kittleson and Associate was involved. Robert Schneider, another colleague from University of Wisconsin-Milwaukee, and NCHRP program officers who basically managed the program, managed the research project, and provided the research there, provided the guidance for the research there. And by the way, Joe Toole is a Cal Poly alum whom I know. He still, I think, believes he works for Kittleson Associates. So just want to give a shout out to him as well. So we'll talk about the background, the project description, and then the guidebook, the how do you do systemic safety analysis that would come out of this. This project, that guidebook, I think is now available. And then how do you basically take the step-by-step process that's in the guidebook, and then we'll talk about some conclusions and then a couple of case studies. And I'm not going to go over in detail, but I'll have you guys review those case studies for yourself. So, systemic approach. What do we mean by systemic approach? So this is Federal Highway Administration talked about systemic safety project selection tool. How do we actually apply systemic safety for selecting which projects to implement for improving safety back in 2013? So this is coming from there. So in a systemic safety approach, we identify a safety concern based on evaluation data at the system or network level. Okay? So we are not going to base our judgment of where to make improvements just based on one location. We are not going to try to identify hotspots and trying to fix them. We are not going to try to go ahead and fix each intersection by each intersection all the time. We are going to identify common characteristics of location where severe crashes frequently occur. And then we're going to try to treat those risk factors, even if the crash data hasn't yet manifested itself at those locations. So this is very important to understand. Like, we are not going to fix, okay, this location saw 6 crashes, so we better go fix that location. No, if a certain location you observe 6 crashes, you are going to identify, okay, what led to those crashes? And instead of trying to fix just that location, when you approve a safety project, you look at, okay, where else in your network those same risk factors exist? And then you come up with a program to fix all those locations at the same time. Okay, so rather than fixing that one location, and maybe you can't fix all of them locations, but you at least identify where the same risk factors exist. And then based on that, you say, okay, here are those locations that I need to fix. And then maybe you can prioritize in some ways, but you're not going to make decisions just on where you noticed one hotspot based on a few years of crash data. So I hope it's clear the difference between sort of a hotspot approach versus more of a systemic approach. In systemic approach, you identify the risk factors and you identify locations based on that have the same risk factor as your hotspots. And then you emphasize low-cost safety countermeasures to address the risk factors identified. So you address the risk factors rather than addressing the hotspot. You address the risk factors. And then you prioritize location based on, you identify prioritize the location based on entire road factors where the risk factors are present, right, regardless of the prior crash history. Okay? So these are the basic ideas of a systemic approach to safety. Okay? So here is sort of what are the benefits of a systemic approach. You improve safety with a more proactive approach because you're not simply chasing the hotspots where crashes have already happened and you're just trying to fix them. You're not chasing your tails with these hotspots. You make informed decision making, utilizing data on key risk factors, and you're able to optimize the investment because you're able to look at cost effectiveness, use of resources, and you have a more consistency in application rather than, just, because just we saw more crashes here, so we're just going to go ahead and fix that. So on the right hand of the slide, the researchers that developed this project, that did this project, show a soft safety approach, a spot safety approach as a most reactive approach. And as you move further down the spectrum, you get to, so they showed 4 different levels of that spectrum. At the most reactive level is the spot safety approach. Make improvements in individual sites or road segments where relatively high number of crashes have occurred. You don't look at sites that have similar risk factors. So that's your soft spot safety approach. Spot safety approach, more of a reactive approach. The second thing is the corridor retrofit approach. That's where you look at the whole corridor. You've tried to fix the whole corridor. You look at all adjacent locations that may possibly have similar risk factors, but you look at the corridor to make sure that you're not just sort of fixing one hotspot and it's just migrating the safety problem. Because sometimes when we take the hotspot approach, we don't actually fix the problem. We just move the problem to another location. So taking this approach makes it a little bit more proactive in that you are treating all the adjacent location, with possibly looking at risk factors as well. And even though not all of those locations that you see in the corridor retrofit approach have seen that same high risk. So there is only one location that saw high frequency of crashes, but you try to treat all those intersections that lie along those corridors. And now we come to systemic approach. Makes improvement as location with a high predicted crash risk or presence of key risk factors, regardless of the actual crash history. So if you see this location as high crash risk, but there are some similar locations like these 6 intersections, these 5 additional intersections that have the same risk factors present. So when I talk about risk factors, what do I mean by that? Can anybody think of when I say that key risk factors, what do I mean by that? Any thoughts on key risk factors? How do you even look at those key risk factors? So I'm saying don't just rely on high frequency crash data that have occurred on one location. Look for key risk factors. So what might those be? Any thoughts? You wanna give me the information via the chat window? I see some responses in chat there. Okay. Speed, yes, speed is one risk factor. So if you see a lot of speeding related crashes on one segment of the road, and then you say, okay, I'm gonna try to lower the speed here. Let's see what the causes of the speeds are here or causes of speeding are. But then you try to see, okay, what other segments that I have that might be susceptible to speeding. So that's a great point. So if you have a location or a segment with high speeding related crashes, you try to come up with a speed reduction approach, not just for that segment. You evaluate where else in your network there are segments that might have a speeding issue, and then you try to treat them systemically. Yeah, that's exactly what I'm talking about. Let me give you another example that I had in mind personally. So let's think about a signalized intersection where you've had a lot of pedestrian crashes, and you look at pedestrian crashes and you notice that, hey, I'm noticing a lot of pedestrians are colliding with, are being hit by right turning vehicles. So your approach might be, okay, maybe I need to do something about that right turn on red thing. So when my pedestrians are going, it looks like what's happening is that I'm running into that issue of pedestrians starting to walk, but the right turners are not seeing the pedestrians they're starting to walk, right? So my hotspot approach would be that I treat just that intersection where I saw high frequency of pedestrian crashes. But a systemic approach would be that, hey, let's see what other intersections have that same issue similar to this intersection. Maybe there is a visibility issue that pedestrians are not able to see things, or there might be just my right turn, or maybe this is an issue like maybe in all downtown signals, for example. So I think this you might be able to relate if you have encountered some things in San Luis Obispo. In San Luis Obispo, and we have Brian here, so he can probably talk about this some more because he's an engineer for the city. But I want to highlight that. So in city of San Luis Obispo, what they did was they basically took all downtown signals and made sure that the pedestrian signal turns, a pedestrian walk signal appears first before the green appears on the, before the green appears on for the through traffic, or like, the right turn traffic, for example. So that is one way of addressing that. Yeah, if the pedestrian walk signal appears first, if there are any pedestrians, they would already be sort of in the walkway before somebody who might be a right turning traffic tries to turn without stopping, right, or without looking. So that's one example of not just trying to fix one location, but implementing similar countermeasures at all locations. And the other advantage of that is that it kind of looks at, it provides more of a consistent experience. So if you make any changes and those changes are throughout your system, then that sort of helps the road users get you more used to it more quickly. And that, I think, is a good thing. And so that's another example of taking a systemic approach. Now, obviously, there is even a more proactive approach could be systematic approach. In systematic approach would be you make improvements at all sites in an area, regardless of predicted crash risk or crash history. So you neither look at either thing, you just fix everything. Now, obviously, this would be more proactive. The problem is we are resource constrained, right? We cannot always take a systematic approach versus systemic approach. So I hope you can, so systemic versus systematic are two different things, right? A systematic approach is basically we are able to fix everything. We're able to fix like all speeding issues, and we're able to slow down everywhere, or we are able to implement these types of countermeasures like flashing yellow arrow everywhere. But we are not able to do that at most times. So what we take is a good compromise to still being proactive could be a systemic approach. We identify the risk factors and then we implement improvements where we see these risk factors appear. Okay. Any questions so far about systemic approach versus systematic approach? Any comments about? I hope all of you can describe the differences between chasing the hot spots and fixing just one location versus taking a more systemic approach of looking at the same risk factors everywhere in your network and then prioritizing based off of that. Okay, so I don't see any questions here, so that's great. So the key takeaway is the definition. I will let you guys read the definition for a minute here. And so let's take maybe 9 or 7. So let's take maybe 2 minutes to read through this definition and let me know if it makes sense from what you've heard from me so far. Okay, so take a couple of minutes and see if that all makes sense based on what we've heard, and if that definition makes sense. Okay, I'll be right back, folks. Just gonna grab some water here. Okay, so any questions about this approach? So just one quick thing note about here is that you're not just focused. So it doesn't mean that you disregard crash history. You actually take the crash history and you say, okay, why are these crashes happening here, and how we can take care of those same risk factors if they exist elsewhere in our network. Okay? And then maybe propose. And I think the systemic safety approach is now being looked at more favorably by the people who make decisions on your grants. Like, if you're a city or a community that wants to apply for safety dollars, for example, the Highway Safety Improvement Program funds from Caltrans. So when you apply for this, but you can show that, hey, so sometimes this might reduce your benefit cost numbers because you're treating locations that may not yet have a lot of crashes. So there was this barrier that existed, or that still exists in some ways, that you drive down your benefit cost ratio. But I think those decision makers are now more aware of the benefits of this systemic approach because the federal highway has been pushing it. So taking a systemic approach is becoming more beneficial if you're applying for those grant funds than it used to be. Because earlier, if you take a systemic approach, and because you're including locations that actually haven't had so many crashes, then sometimes your benefit cost ratios could look worse than somebody who is not taking a systemic approach, or somebody who's taking more of a hotspot approach, because they're only focusing on improving locations that have had a lot of crashes, right? So now I think there is a realization that yes, we don't need necessarily have to kind of guide ourselves just by benefit cost ratio, because if we did that, then we might be just always be you taking that hotspot chasing approach, which is not always the best idea, because we want to be proactive in our safety improvement. Okay, so I'm taking there are no questions here. Let's go next here. So what is the systemic approach to safety? How do we do it? Identify focus crash types and risk factors. Then you screen the network to identify locations with relevant risks for treatment. The same relevant risk, right? So we figure out, okay, I want to focus on, so this is the first step, is where the crash data is very important. You want to look at, okay, at a system level, what type of problem am I having? And you could look at historical trends here as well. Say, hey, my pedestrian crashes used to be really low here, but now they've gone up some. What happened, right? So it could be that, when you identify your focus crash risk type, you look at the aggregate crash data or the community-wide crash data, and then you come up with, okay, what trends am I seeing in my community? And then based on that, you identify, okay, my focus for this safety improvement program would be pedestrian crashes or bicyclist crashes, for example, right? And you try to treat those bicyclist crashes, and then you say, okay, what type of bicyclist crash am I seeing? And then you look at, obviously you'll find, you might find some hotspots, but instead of just treating those hotspots, you say, okay, why are those locations the hotspots? So you identify risk factors, and then you screen your entire network for those risk factors that exist. And then you identify candidate countermeasures to address those risk factors. And then you prioritize projects, and you say, okay, I'm going to pick, maybe 10 of these locations or 15 of those locations. And then you allocate the funding. You find funding somehow through grant programs or whatever. And then you allocate whatever funding you have available. And then you evaluate actually what happened, and then you could do empirical based type stuff after you implement improvements. You can do empirical based type stuff to actually assess how much improvement did you actually make. Okay? And that sort of is the process for doing for implementing the systemic approach to safety. So element 1, as you could see, is more of a planning element. It's basically involved crash data analysis, prioritizing, selecting the countermeasure. Element 2 is basically actually finding the funding and then implementing the program, actually doing the work. And element 3 is evaluating what happened. And you will see that we are, so element 1 is planning, and what highway safety improvement program by Caltrans is doing now is that they are emphasizing communities do this element 1 all the time, not just for the grant writing purposes, but do a continuous monitoring so that whenever a funding source becomes available, they are ready to implement element 2. Excuse me. Okay. Element 3 is something that we are not still very good at. I mean, it's hard enough to do these safety improvements, and we're not yet very good at going back and evaluating and see what worked and what didn't work. But I think that's still a very important element of the program. But again, that is based on more reactive approaches. You do empirical based type stuff that you learned already in this class, then that becomes more of a reactive approach. So we make improvements using proactive approaches here. But once we do that, then we might want to look at, okay, how do we evaluate what we did has been pretty good or not? But because these proactive systemic safety approaches are fairly new, we haven't yet dug deep into evaluation programs as of yet. But that is not to say that you shouldn't take proactive approaches. Proactive approaches are still, I think, is the right way to go about doing safety improvements at the community level. Okay? And there is some resources available from Caltrans now for communities to do this element 1 on a continuous basis, on an ongoing basis, so that they are ready for writing the grants whenever funding programs become available. Now, what we've talked about so far has just been about overall systemic safety approach or a systemic safety process. I haven't yet mentioned pedestrians. As you recall, the researchers that did this NCHRP project, they were in fact interested in pedestrian related crashes. And what they said was that pedestrian crashes, because they're rarer and they're widely dispersed across a network, the hotspot approach is particularly unreliable for these types of crashes. It's particularly cost ineffective. So same thing goes for bicyclist crashes as well. So for pedestrians and bicyclist crashes, this proactive approach is even more important. You can get away with chasing hotspots if you are talking about just the automobile crashes. You might still, because automobile crashes are frequent enough that you might be stumbling on. So the crash history will typically manifest itself at all locations where the risk factors are present, because automobile crashes are frequent enough and not as, so you can expect automobile crashes to be manifesting themselves wherever the risk factors are present. But pedestrians and bicyclist crashes, because there are few pedestrians and fewer bicyclists, the pedestrians and bicyclist crashes might not reflect, they might be more widely dispersed across a network, and they might not be, so hotspots based approach might be particularly bad for these types of crashes that are rarer or widely dispersed. Okay? And crash risks for pedestrians are different than for motor vehicles, and there is a need for specific guidance and research to augment existing tools and guides. And then the process needs to be tailored, related to data, related to pedestrians, and guidance housed to gather the needed data. So that's why they've tried to focus on a systemic safety process specific to pedestrians, and this project did. So the project description was to develop a guidebook of doing that, right? So analytical methods to identify roadway features, behaviors, and other risk factors associated with pedestrian crashes, and then identify appropriate and cost-effective systemic pedestrian safety improvements that you can implement on a system-wide basis, and then information to enable transportation agencies to prioritize candidates for selected safety improvements. So this guidebook provides the guidebook that they developed as part of this project that provides that information. And I'll make sure that I will have the tool book available for you to read through. I'll not ask you to read through the whole thing, but I'll make it available so in case you end up working at a community for a city or for an agency that wants to do something like that, that guidebook could be a very, very valuable resource. But I think what I'll make sure is that for this test of this class, if you reviewed this PowerPoint and the lecture that we are recording right now, you will probably be covered for anything. But if you're curious, you can dig into more information from that guidebook. So this is the elements of the guidebook, the overview, the process steps, and some examples. And then I will also have a couple of examples listed out as part of this presentation at the end of it, but you can read through that. So this guidebook provides these 7 steps. Define the study scope. So again, you don't want to focus your study scope to be too broad. You look at the crash data, maybe you're alarmed by certain increases. So you say, okay, I'm going to focus on just those types of crashes. But it's important to define the study scope. That, hey, I want to look at speeding related crashes, or I want to look at pedestrian related crashes that happen on mid-block, or I want to look at pedestrian related crashes that happen only on signalized intersection. So that you identify the study scope and then you compile the relevant data. And based on that compiled data, you identify risk factors, and then you identify potential treatment sites. Some of those step 4 sites might be hotspots, but a lot of them might not be hotspots. Okay, so you have to sort of look at that holistically, look at your whole network and identify potential treatment improvement sites, and then potential countermeasures, what those countermeasures could be that you can implement system-wide. And then you refine and implement treatment plan. So step 6 is where you'll need the money. And then step 7 is you evaluate the program impact. And then you do this for some other pedestrian issue that you notice. So basically a cyclical process of analysis whereby you can analyze, implement, and then evaluate. So this first element is the analyze element, and then you have the implement element, and then you have the evaluate element. So the 3 elements that I showed you in this side, element 1 is basically analysis, element 2 is implementation, element 3 is evaluation. So for example, they took so this could be one example of identifying the scope of the problem. Okay, so what they did was, okay, they looked at total crashes, all pedestrian crashes. There were, let's say, there were 1,817 element crashes. 55% of them occurred on urban areas, 45 occurred in rural areas, and then you further divided them into non-intersection, intersection and intersection related, and non-roadway related. And then you could look at non-intersection. So you kind of did a further breakdown of crashes. And then you did, like, for intersection related, you did the control type. And then you look at, okay, this is what that control type looks like. But then when you looked at the non-intersection related crashes, you said, okay, 17% of all of this 1817 crashes occurred on 2-lane undivided crashes. So this becomes your focus area. And then for rural areas, 2-way undivided also is another focus area, right? Because you're seeing maximum number of crashes occur here. So what you do is that becomes your focus areas. Okay, I'm going to look at all of my two-way undivided roadway segments and look at pedestrian crashes there and see what are the risk factors associated with that. So you still rely on crash data to identify what the problem is. So in this case, you use the crash data to define the study scope that accounts for a larger percentage of the problem would be a good approach. So this is the, you can come up with descriptive crash tree diagrams like this, and then you can see that based on this. Now, this high percentage by itself might not be the approach that you take, but this is one of the approaches. The other approach could be where you're seeing maximum increases, right? Maybe because your community is changing in a certain way, and now you're seeing a certain type of crashes increase over time, right? For example, let's say, and I don't know if you noticed this, but due to COVID-19, a lot of locations saw an increase in bicyclists all across the country, really. A lot of people started bicycling more. So if you look at the crash data and you start to see, okay, my crash numbers for bicyclists in 2019 versus 2020, I'm seeing a significant increase in bicyclist collision and bicyclist fatality. Now you say, okay, and because my bicyclists have gone up. So even though that itself might not be like the most important type of crash that you're seeing, but maybe because you know that your bicyclist crashes have increased so much from past year, and you expect that count to, people are bicycling more and you want to encourage more bicycling. So you want to treat the bicyclist type crashes. So you could do this for bicyclist crashes as well, right? So having high percentage of crashes is one way of identifying the problem or defining the study scope, but that by all means, it's not the only way. You can look at increases as well, but you can exercise your judgment here because defining the study scope is in your hand. And sometimes this might also be dependent upon what is the focus of the program where you're going to get your funding from. So maybe the program where you're going to get your funding from has a special focus on bicyclist crashes or pedestrian crashes or certain other types of crashes. So maybe you have to tailor your study scope according to that. So there might be different ways of dealing with that. One good approach is to look at problem type that accounts a larger percentage of the problem that's shown in this slide, but that by no means is the only way of defining your study scope. Okay? I hope that's clear here. Are there any questions about this? Any questions here? No questions. That's great. Step 2 is you compile all the data, and this is where you need to have. This is where really that you need to have digitized, easy accessible, centralized data throughout your community that's linkable across databases and especially referenced so that you know which location. And recommended data for systemic analysis include crash records. And again, pedestrian was specific to this project, but if you remove the word pedestrian, this is sort of the systemic analysis you could do for any type of crashes. You want to relate your detailed roadway data with key characteristics such as number of lanes, and then vehicle traffic and pedestrian volumes, or secondary data to estimate volumes like transit ridership, population. So some ways of measuring the exposure. And then if you have other measures of built and social environment and changes in those environments as well. So you could see, so there might be some data that's absolutely is required. You want to have those, and then what the data you need to have for systemic safety. So that data, more and more communities are now gathering because, for highway safety improvement program funding, you start to, they're asking the communities to take a more data-driven approach. So that this become very, very important now. And then you identify crash risk factors from regression modeling of the jurisdiction-wide data. So this could be just trying to develop safety performance function, or you can look at safety performance functions that other people have developed, right? You could look at what factors did the other studies found significant as well. And the alternative approach, it could be From prior research plus local judgment, Infer risk factors from roadway and crash frequency data type analysis, you could see where your high crash frequencies are occurring. And based on that, you could say, okay, if there is like maybe there are crashes that are related to right turn on red, so you try to treat that. But you want to take a more data-driven approach. Either you develop your own SPF, if that is too cumbersome for you, you look at prior research and local judgment, or you can look at crash frequency and then see what might be causing those specific types of crashes, and then you look for the same risk factors elsewhere in your network. So there are some advantages of the modeling SPF approach. Because it's a data intensive approach, it can expedite your subsequent steps because you already have the data. And then it's more reliable than other methods because you're able to address that randomness of identifying sites with more than average crash risk. Simultaneous accounts for multiple risk factors, accounts for the local context. But the problem is that modeling and creating an SPF required some sort of some ability to handle negative binomial regression model, for example, right? And that's why it might not be something that everybody could do, and that's why they specified some alternative approaches as well, even though it is the best practice currently that exists. So you want to be able to model your own crashes based on the safety performance function approach, even though it might not be feasible for every agency. If that's not feasible for that agency, they can take the alternative approaches that I mentioned earlier. So based on that, you identify treatable risk factors. Treatable risk factors could be presence of one or more mid-box sidewalks, number of through lanes when they go up, number of pedestrian crashes go up. When there is two-way left turn lane, then the mid-box pedestrian crashes go up as well. So basically what they're going with is they're saying, so they're sort of building off of this chart, right? So they're looking at which locations are at most risk of having pedestrian crashes at non-intersection locations that are two-way undivided roads. Two-way undivided roads, and they identify these risk factors for that. Okay. And then you start to see, okay, how can I treat one or more of these risk factors through a systemic approach? Now, some of these locations where you have these risk factors, they might not still have high crash frequency. Okay? But you are identifying these risk factors and still trying to treat them. Okay, because you know these factors are in fact associated with high crash frequency. Okay, so if you don't develop your own SPF, you could find risk factors based on prior research. So prior research say, okay, the pedestrians are more likely to have fatal crashes at these locations where there are multiple roads, there's a lack of separation in space or time, higher speed traffic, commercial driveways, transit activity, and those kind of things. So you could look at, okay, I'm going to try to treat, so transit activity could be a great example, right? So we know that where more transit activity happens, where there are more transit stops, you know there's going to be more pedestrian activity as well. So say, okay, I'm going to take a systemic safety approach for transit safety. So I'm going to try to treat all my transit stops for pedestrian-related improvement. And that could be a great way of selecting things, even though it's not the most recommended way. Even though you're not developing your NSPF, you can say, okay, I'm going to treat all my transit stops and nearby locations for pedestrian-related improvements, because you know that's a risk factor. Because we know where the bus goes, there are bound to be pedestrians. Okay, so this is one of the alternate methods. So you can look at any of these things and try to start fixing one of those things. Risk factors from road and crash data. So here, you come up with more of a here you develop like more of a contingency table. So let's say you have 1,215 crashes, pedestrian crashes in your community. You try to develop like a frequency table, like the one you already developed in one of the labs. So you look at crashes on urban arterials, you're looking at crashes on urban arterials, and it looks like there were 1,215 crashes on urban arterials in your community. And then you say, okay, I'm going to divide them 5 different crash types. Okay, 5 different pedestrian crash types and 5 different location types. So I'm going to have a 2x2 contingency table between crash type and location type. And I'm going to divide all my 1,215 crashes into that 2-way contingency table. Okay? And then I'm going to try to see where most of my problem lies in my region. Okay? So when you do this type of analysis, you will see that on location type 1 and location type 1 and crash type 2, there are 67 such crashes. But if you look at location type 3 and crash type 3, there are 98 such crashes. But if you look at location type 4 and crash type 4, there are only 2 crashes like that. Okay? Now, what do I mean by location type 3, 1, 2, 3, 4, and 5? This could be something that could be of interest. That could be, okay, it's an intersection type crash, and you could define that, like, you can define that based on your own criteria. So there are, so you could say, okay, and so each of these location type are based on whether or not it's an intersection, what's the ADT, what's the speed limit, and what's the number of lanes, and if the traffic signal is present or not. Right? So these could be ways of identifying certain types of site. Crash type could be if it involved a turning vehicle, if it happened at mid-block, if it was alcohol was involved. So there could be like different crash types that you're dealing with. But this type of a table could help you pin down, hey, I only have 51 type 3 sites in my location, but they're accounting for 98 of my crashes. Right? So that's sort of a problem. And you could see location type 4, there are only 25 location type 4. They are accounting for 171 total crashes. Okay, so that might be another sort of a risk factor that might be present. So you look for a combination of location type versus crash type that lead to most crashes. So you could see this 98 crashes is the highest frequency that you observe. So that means treating turning vehicle type crashes at location type 3 might be a bang for your buck type of proposition, right? So what is crash type 3? Let's say the crash type 3 was turning vehicle, and turning vehicle related crashes tend to occur at these type of location type 3, which for me was intersection without a signal, ADT less than 10,000, speed less than 45 miles per hour, and 3 to 4 lanes. Okay. So I'm going to start to see, okay, 98 pedestrian crashes for crash type 3 and location type 3. So I'm going to start to say, okay, this is going to be my focus area now. So I'm going to try to see how can I treat turning vehicle type crashes at this type of location. And if I'm looking for more risk factors, I might want to look at where I had 80 crashes, I had 289 number of sites, and crash type was 3. So this might be like, where you have signalized intersections, for example, with these characteristics. Okay. I can look at this 77 crashes type location where location type is 2 and crash type is 5. Whatever that type happens to be, you would know that as an analyst. So you can start to see, okay, I will look for where I see the highest frequency, And then based on that, I'll decide what things to fix. So any questions about this slide? I know this is a lot to take in. So I want to give you an opportunity to actually maybe even take 5 minutes break here. Or maybe, so let's do this. Let's review this slide and what we've covered so far and take maybe 5-minute break and then maybe spend a couple of minutes looking at this slide and the things that we have covered. And let's gather together at 9:50. And if there are any questions, we can address that and try to wrap up the discussion after that. So let's take a 10-minute break here. I'm going to pause recording. Yes. Okay. Thank you for a reminder, Joshua. Okay. So we were just kind of looking at this slide and asking for any questions. And we're saying you can, once you have this type of data in hand where you can create these types of tables, you can even combine some risk factors and try to see how many sites are out there. And you could see and how many crashes have they had, or what their predicted rank of safety is, or what is their predicted rank for them as a candidate to safety improvement is. And you could see that there are 1,425 sites of this type. And here you can combine roadway factors. Okay, combinations of identifying risk factors can be used to identify and prioritize sites. And then you could talk about what their volumes are. And then you could see that out of the 23,000 total sites, the ranking of these sites falls between 1 to 6,585. Now, that doesn't mean that so all of these sites, there is no site that has this combination of factors, and no sites like this falls below 6,585 ranking. So that means out of your 23,000, this type of site, let me do the laser pointer. Out of the 23,651 total sites, this type of site is never ranked below 6,585. So it's always sort of in that 25th percentile of ranking for safety improvement, according to your analysis. Same thing for site like this, presence of 4 or more through lanes and less than 2,500 ADT. Same thing. So, and the site number 1 obviously is that location, is that type of location as well. And then it could be that there are maybe some combinations here that are to be had there. And then if you go down this further list, there are only 44 such sites, and they fall between 15 to 2,000. So this could be interesting as well, right? Because no site is below 2090 level for safety improvements, although it's not the top rated site, but it's the 15th most 15th most highly ranked site up until, and then they lie within less than 10% of all the most improvements, most prone to this type of crash site, and there are only 44 of those. Okay, so maybe this could be another target. Like even there are only 44 sites like this could be another improvement for target. So you could say, okay, what kind of improvement I can make at these 44 sites, because they're also very important. Or you could look at what is my highest ranked site, because there is number 1 site is located here. And if there are more sites like this, then that might make your job harder, because then you have more sites to improve. You just have to look at that relative bang for your buck here. So how do we do this improvement? So you could look at top 20 intersection. Okay, so you could look at total base, so top 20 based on SPF prediction alone, top 20 based on total crash frequency. So this will be more like a hotspot approach. So if you do just see a dot there, okay, if you just see a dot, that's just based on the history of that site alone. If you look at the pin marker, That's based on SPF prediction, the safety performance prediction. And then if you see a triangle, that's a combination of the two, the empirical Bayes estimate. You guys know about that, of course, right? We've learned that in the class. So if you look at top 20 sites based on the empirical Bayes estimate, you find these top 20 sites. And then you could say, okay, I'm going to target maybe these top 20 sites, even though some of them may not have had a lot of crashes. So that could be one approach of targeting. You could look at, so just going by crash frequency itself might not be the best approach. You can either go by the SPF prediction, or you could go by the empirical Bayes estimate. That is the most statistically defensible thing to do, right? So you could say, okay, I'm going to try to treat these 20 sites. So what is the most effective countermeasure for all of those 20 sites? And then I'm going to try to seek funding for that. And then you select countermeasures for those 20 sites. The criteria would be cost, the feasibility, and the relation to systemic program focus or target crash types. So if your target is pedestrian crashes, you want a countermeasure to focus on pedestrian crashes. You don't want to implement countermeasures that lead to fewer automobile crashes alone, right? So you want to focus your countermeasure that is relevant to your systemic program focus. And then you look at the safety effectiveness. You can consult when you're trying to identify which countermeasure to include here. You could look at the crash modification factor from the CMF clearinghouse that we have shown you before in this class. So you can look at that tool to identify which countermeasure to use. And the selection process is iterative to match the treatment site with potential countermeasures. Okay? Because if your treatment sites are such that if you identify treatment site based on empirical Bayes approach, and the countermeasure there is not relevant, and so you might have to do some iterations between going back and forth between which countermeasure to choose for most important selection sites. And then perform diagnosis at the post-treatment sites to confirm. And you look at that, said, hey, I select this countermeasure, but that countermeasure would actually even work there at that site. That's your selection process there. So, for example, through this process, they came up with 12 recommended countermeasures for the North Carolina data that I showed you earlier. So signalized or unsignalized crossing locations, including mid-block. You want to include high visibility crosswalk. You want to have some traffic calming measures, raising devices, median crossing island, reduce the number of lanes and road diet, curve extension, and location-specific lighting improvements. So this would be for signalized or unsignalized crossing locations. For unsignalized location only, you look at in roadway yield pedestrian sign, pedestrian hybrid beacon where it flashes like you see in downtown San Luis Obispo, and advanced stop yield bars. And then for signalized intersection only, or the signal is recommended to be added, so you include the leading pedestrian interval. That's the one that I was talking about, where the green for the pedestrian or the walking person for the pedestrian occurs sooner than the green light for the through automobile traffic. And then you could have a restricted left turn. You might have seen that. We talked about that in the human factors approach, this type of thing, where the restricted left turn, where you expect high pedestrian activity. And then you talk about the longer pedestrian phases. That could be only for the signalized intersection. So they came up with these for the North Carolina site that I showed you at the very beginning, that tree type of diagram. They came up with these 12 recommended measures that as you can see, they differ from the location context, right? For each different location context, they are recommending different countermeasures. And this is something that you might have to do fairly often. Okay, so risk factor was presence of a mid-block or crosswalk. There were 196 slides. You want to make all those things high visibility crosswalk, and the other countermeasures that we saw before. And through or five, so which is at mid-block crosswalk and 4 or 5 through lanes. And then for those 4 or 5 through lanes, you can have these things, right? You can do these things, and you have on-street parking. So if you have all 3 things available at a site, you only have 12 such sites where you might want to do all of these things, and you might want to do curb extension and parking restrictions. Okay? So these are your countermeasures. So you can see that whenever you see a line like this, and like we saw before, so there are only 4 to 5 lanes, two-way left turn lane and parking sites. There are only 44 of these. And then you add presence of two-way left turn lane, then you become 4 to 5 plus lanes. And you remove the parking restriction, you go to 279. You can now say, okay, I want to look at sites with less than 25,000 ADT. Then the sites, sort of number of sites go up, and then you sort of, as you remove restrictions, you have more of those sites. As you add restrictions, you have fewer and fewer of those sites. So you basically add the parking restriction, and you only have 44 sites. So you sort of start looking at presence of 4 to 5 through lanes and non-zero pedestrian volumes. Then you go less than 25,000 ADT, and then you go and add two-way left turn lane, then you have fewer sites, and then you add parking, then you have even fewer sites. And you could sort of, that's how you're going down that list. And then same thing is happening here. You have total mid-walk crosswalks 196. 26 of those crosswalks are with 4 or 5 through lanes, and then 12 of those crosswalks are with on-street parking. So here are countermeasures for the 196 sites. Here are additional countermeasures for only for those 26 sites, and additional countermeasures for only those 12 sites. So your countermeasure has to be in context with the situation that you have ongoing. And then you refine the implement treatment plan. This is where you actually do the benefit cost analysis. This is where you refine and implement the treatment plan. So for implementation, you might need to, so there might be grant writing involved here as well. So once you prioritize, you finalize the plan, you write your grant, you get your funding, and this is where that comes in. And I'll try to see if I can get you an example of the grant writing that one of my students did before, and I can share that with you. I won't be able to go into too much detail of that grant writing part of it, but I'll definitely be able to share a template with you as to how this grant writing and prioritization is actually done in practice. So I'll share that with you beyond what you see in the NCHRP research. I think the example that I have is from West Sacramento, from one of my past students. So I'll share that with you. And then once you've implemented things, then you evaluate the project and processes. But evaluation, so there are some limitations to this. Part of that is data. If you don't have good data, you won't be able to do a robust systemic safety analysis. We don't have as much good data on behavior type risk factors or examples. So we have good data on risk practices that lead to design aspects, like 4 or 5 roadway lanes and all that. But we don't still have good data on behavior-based factors like how do we do drunk driving related things and where the speedings are happening and so forth. Evaluation, step 6 and 7, we don't have good information. There is very limited research on evaluation of systemic safety approaches. Have they really been effective in reducing crashes? There's not as much data out there. CMFs for treatments applied systematically may differ from those applied based on crash history, right? We know that for sure, because crash history-based CMF sometimes might tend to overestimate, but I think you can minimize that impact by using approaches like the empirical base. And then there are, you can see more rational caveats and consideration in the final report. Again, you don't have to worry about this for the purposes of this class, but ultimately, if you become a safety professional and you're looking at this, you might want to refer to these for more caveats that they provide as well. And this also provides interagency collaboration opportunities, because sometimes we don't have that issue necessarily in San Luis Obispo. But if you go to a larger metropolitan area, there might be city boundaries that exist between multiple cities. There might be roads maintained by cities and county. So there are some interagency, like if you're trying to implement systemic safety approaches, you might have to look at data just beyond your immediate jurisdiction. You might have to go a little bit outside of that. So there might be opportunities there. And then you could do training and skills and tools and methodologies for different contexts. And you could do those types of training for a number of jurisdictions together. And then countermeasure evaluation could also be conducted, over different jurisdictions that are contiguous in nature, that are side by side. Maybe, for example, in Los Angeles area or in the Bay Area, you might have different cities boundaries that overlap. Now, even in the same urban areas, there might be arterial streets that some segment fall in one jurisdiction and some other segment that fall in another jurisdiction. So I think there is some collaboration opportunities, but they list that as opportunities, but sometimes it comes with challenges as well. So maybe some collaboration here might be helpful, because your goal is overall to improve safety, and you might be better off looking at that safety systemically, even though the locations might be managed by different jurisdictions. We talk about some future research needs as well. And those future research needs are related to evaluation, related to behavior-based risk factors such as speeding and pedestrian crossing behaviors, evaluation of safety impacts of treatments and systemic applications. So we haven't really been doing a lot of systemic applications. We've been doing mostly countermeasures that are implemented based on hotspot chasing. So systemic safety is still relatively new. So we need to do more research on evaluation piece. We have to look at pooled resources so that we are doing more collaboration across jurisdictions and evaluating the safety impacts of systemic versus traditional approaches. We haven't seen that. We believe systemic approaches are better, but we need to kind of gather more data on how much better they are, so to quantifying the benefits of the systemic approach. But we do believe right now that instead of chasing hotspots, we might be better off looking at systemically. Because the other advantage of doing systemic improvements is that if your goal is to have more pedestrian or more bicyclist or more transit activity, and you improve the system as a whole, or you try to implement improvements as a whole, then you increase or you encourage more pedestrian use or more bicyclist use, because the users see that improvement system-wide. And that, I think, there is that benefit as well. But we need to do a study of how much extra safety benefits are we getting by taking a systemic approach. There is need to be doing more research. Okay, so what I'm going to do is I'm going to stop here. I'm going to have you guys look at the remaining of these slides. Okay, on the example is of Seattle and how they implemented sort of a systemic approach for Seattle, and then the second case studies from Arizona DOT pedestrian analysis as well by Kimberly Horn. So you might want to look at that as well. So they basically are doing what we talked about right now, and they talk about benefit cost analysis, and they also talk about how there was how they conducted road safety audit as a countermeasure as well. And road safety audit sort of provides a segue to what we are going to be doing. So what I want to do is I want you guys to make sure that you guys review this before the next class, before the next coming Tuesday. Make sure you review this. And then I'm going to kind of give you a little bit more. I'm not going to talk about these two case studies because you will have reviewed them. And if you have any questions, please let me know. But I'll talk about, maybe I'll give you another example from West Sacramento, where they also implemented something similar. And we'll sort of try to look at how that process, how what we talked about in slides today translates to these case studies. Okay? So your assignment, sort of your reading assignment for this is to review the slides that we did cover today, look at the case studies that are out there. And then once you're prepared, coming Tuesday, next week, we'll have a guest speaker, but then also we'll talk about how that case study was implemented in a typical systemic safety case study was implemented in West Sacramento as well. Okay, so I'll stop here with this presentation unless there are any questions. And also pause recording here as well. So welcome back. I want to talk to you about your next assignment on road safety audit. So road safety audit is a process where, again, part of a proactive assessment of traffic safety. And in this, a team of road safety professionals that are trained in road safety audit, they visit a roadway location. It could be, a roadway that's about to be built, a project that's about to be delivered, but it could also be an existing roadway as well. So road safety audit process typically started from where a roadway facility was about to be handed over to the public. And that's where a team of experts used to visit that site and identify any potential safety issues that they might notice at that location. And basically you go out with a checklist to the site. Now, but road safety audit could be conducted on existing roadway facility as well. So that's always a thing to do. And it always happens. And when we had this class in a regular sort of in-person mode, we used to do sort of more of a community engagement project where I used to take the students as a group to a local school location, and we used to do a road safety audit analysis for that school. So we used to look at, okay, where the students are crossing the roads, what kind of facilities are available for crossing, what type of crash avoidance countermeasures are in place, where the students might have problem. We've also done this type of work for on-campus locations as well. And I usually make a checklist available for every group. And then we sort of go out in the field and evaluate the location, compare that to the checklist. And then we provide a report, okay, so here are the problems we noticed according to this checklist, and then what kind of countermeasures could potentially be implemented here at this location. So you become sort of a road user / expert that visits the site. Now this year, obviously, we are all virtual and we are at different locations. So here is my approach of trying to get that road safety audit project off the ground. And I'm still sort of looking for inputs, but my plan is to have divided you guys into groups of 5. And I'm doing a little bit larger group this time because my goal is to have at least one person in each group. So I'm hoping by having such a large group, I will have one person in each group that can go to the field, go to a nearby elementary school, and potentially video record the location against which your group can then evaluate the checklist that I'm going to share with you guys. So that sort of is my plan. And I would very much like your feedback. Obviously, we're going to spend some time sort of doing some of the work this Thursday. And maybe what we do is maybe we video record more than one site per group and then come together as a group to do work on this. But for now, my goal is to have you guys join the breakout room corresponding to your group, because I've divided you guys into 5 road safety audit groups. Join the breakout room, discuss among yourself if it is who has the most convenient access to an elementary school, so that you guys or that person could go down to the field to do a road safety audit, like by video. And then you guys as a team can look at that video and see if you can fill out that checklist. So our goal will be to look at that checklist, try to see if we can capture a roadway location, a roadway segment near a school, elementary school, and identify safety problems that might potentially exist near that location. So that's going to be the assignment. And I'm going to share, obviously, the checklist with you. So instead of doing in-person site visit, our goal will be to have at least one of our group members record the video and identify. Now, let's see if you guys don't feel comfortable or you cannot identify a location, then we might have to make some alternate plans here. But our goal is at least to see if we can, and I think sometimes it's helpful to have the perspective of a pedestrian, a motorist, or a bicyclist, or a bicyclist, all three perspectives sort of incorporated within the road safety audit process. But again, I don't expect you to be able to, put on a GoPro and ride the bike at the roadway location. That's not something that we want to do. It probably will not be safe. So I just want you to kind of go as a pedestrian for now and just record and try to capture as many elements of that location as possible. And maybe just one of you has to do that. So are there any sort of questions broadly about the assignment that you guys, that I'm sort of laying out here? Do you anticipate any huge issues other than, of course, that none of the people in your group is conveniently located near an elementary school, so you can't get the data? Other than that, we'll figure out that problem when we talk amongst our groups. But if other than that issue, you guys see any issue with sort of relying on road safety audit project, relying on the video data for a road safety audit project? Any questions at all? You can type questions in the chat box as well. Okay, if there are no further questions, what I would like you to do is go to the breakout room. Let me pause the recording first.